We're going to look at the addition rule today. And the addition rule has to do with the word or. The probability that an event A or B will occur. So anytime you see the word or in a probability question, odds are you're going to have to be doing some adding, and sometimes you'll be doing some subtracting. If the two events are mutually exclusive, then we just add the probability of A and B. Now remember, mutually exclusive could be explained by looking at a Venn diagram. If the circles did not overlap, they were mutually exclusive or disjoint. If they did overlap, they were not mutually exclusive. They were not disjoint. So if you have overlap, if they're not disjoint, then you've got to do some subtracting. So we have to decide, do I subtract or not? We always add, and sometimes we subtract, sometimes we don't. You roll a die, find the probability that you roll a number that's less than a 3, or you roll a 4. Well, the numbers that are less than a 3 are the numbers 1 and 2. Rolling a 4 is 4, so there's no way that you can roll a die one time and get that roll to be a 1 or a 2 and to also be a 4. So they're mutually exclusive. So what we have to do is just add the two events. No subtracting required here. There's 2 out of 6 that are 1 or a 2. There's 1 out of 6 that's a 4. So we get 3/6 when we add them together, or 0.5. Here's another example. Find the probability that a randomly selected card is a jack or the card is a heart. Now remember, a deck of cards has 52 cards, 4 suits, hearts, diamonds, clubs, and spades, and each suit has 13 cards in it. Now there's 4 jacks and there's 13 hearts, and the jack of hearts then would fit into both groups. So they're not mutually exclusive. So if all we do is add the probability of picking a jack and add the probability of picking a heart, what we've done is counted the jack of hearts twice. And that's why we have to subtract this one card out of the 52 that we have. Otherwise, we count the jack of hearts twice. Here's another one. This one's set up in a table. So we've got 100 college students. How many hours a week do you spend studying? We want the probability that a student spends between 5 and 10 hours or more, or more than 10 hours studying. Now, if you notice, you can't be in both groups. I can't pick one person who's going to say they fit into both of those categories. So they are mutually exclusive, so I don't need to do any subtracting here. I take the 46 5 to 10s, add them to the 30 more than 10s, and I get 0.76 for my probability.